All right, guys, welcome back. Equation Series B. Now we're looking at solving two steps today. If you did not watch the one-step video or you were not clear on one steps, I would recommend going back and watching that again because everything we do with a two-step is just building on top of how to do a one-step. All right, let's dive in. This is just a little bit of review from yesterday. Again, we got to make sure we understand this stuff. So we've got this one-step equation here. P is on the right side, so this is the value we're going to cancel and get rid of. It's a minus 5, so I'm going to add 5 to cancel it. And to be clear, some folks might look at the sign in between and think that means subtract. But remember, that sign goes with the P. It goes to what's behind that operation symbol. So the 5 is actually negative. It's a negative 5. So we want to add 5 to cancel it. That's what's going to get rid of it. 5 bad guys, we bring 5 good guys, and that cancels away, leaving P by itself. Okay, we'll do the same thing on the other side. We're following our two rules. Rule number 1. Make sure we're using the opposite operation to cancel whatever we need to cancel off. And then rule number 2, make sure we do the same thing on both sides to keep the equation balanced. And I think I just reversed those as for how I taught them in the video yesterday. It doesn't matter. Just make sure you remember those two things. All right, number 2, same idea. That negative 7x is multiplying, so I'm going to use division to cancel it. I'm going to divide off both the 7 and the negative. So I want them both to go so that x is by itself. I'll do the same on both sides. I'm going to end up with negative 3. Okay, hopefully you're tracking with me and that made total sense. We're going to jump in. All right, negative variables. This is something you'll often see. I didn't introduce that yesterday with one steps because I thought we had enough going on there, but let's look now. This first example, again, we're looking at the 13. We want to cancel off the 13. And we might see that subtraction and think we need to add. But again, the subtraction goes with what's behind it. That's paired with the x. So we actually are looking at the sign of the 13. Nothing's there, so we know it's positive. If I want to get rid of a positive 13 or 13 good guys because they're connected to the x by add or subtract, that means they're good guys or bad guys. And there's a positive 13, they're good guys. I'm going to subtract with negative 13 bad guys. I'm going to do the same on both sides. I'm going to add negative 7 and negative 13. Remember, that's just two groups of bad guys. You can put the plus in the middle like we were doing before when we were doing it horizontally. Now they're just vertical, but it's the same idea. So I've got negative 20. And if you're not careful, we would do this. I will often see this when kids are first learning. But if we do that, we left this guy out. There's a negative, and that negative stays in the problem until you deal with it. So it's actually negative x. What do we do? If you write that on a quiz, you're correct up to this point, but this is what we want to see for the final answer. I want to know what x equals, not what negative x or opposite x equals. So you need to go one step further to get your full points and get it fully correct. And what do you think it is? If negative x is negative 20, what do you think positive x is? I bet you're all saying 20. Good job. It is as simple as that. You can cancel the negative on both sides. It's as simple as that. All right, let's look at the second one. Negative y over 4. That 4 is dividing. So to get rid of it, we're going to use the opposite operation. We're going to multiply and do the same on both sides to keep the equation balanced. Now we know to keep the negative with y, and we end up with 48 here. And again, we need to get to a final solution of y, not negative y. And what do you think that's going to be? There's no negative on this side to cancel, but the principle's still true. We're just going to flip the sign on both sides. That's actually what we did on number 1 over here. We just flipped the sign on both sides. They happen to both be negative, so they both became positive, but the principle is the same. I'm going to cancel that sign, which means I'm going to flip the sign on the other side, and that's also a valid equation. If the negative y was 48, then positive y equals negative 48. We can flip that sign, If you want to think about it in terms of our solving principles we've been learning, we can always do the same to both sides. Think of it as multiplying both sides by a -1. That always keeps an equation balanced if we do the same thing to both sides. So then we get a cancellation of these two negatives, making positive y, and then when we multiply that -1 times 48, that's how we get the -48. All right? Go ahead and pause me and do these two right now. Wow, look at all those negatives. And I use 9s and p's a lot. Pause it, you do this. All right, let's jump back in. Here, I've got the -p minus 8. The 8 is what I want to target and get rid of. So 8 bad guys, 8 good guys, they're going to cancel. Do the same to both sides. That's going to keep my equation balanced. -9 and 8, that's 9 bad guys, 8 good guys. They're going to subtract and cancel. 1 is left over. There were more bad guys, that's why we have a negative answer. And we're down to -p. So at this point, we want to solve for positive p. So we're just going to cancel negatives on both sides. Another way to say that is just flip the sign on both sides. So we see that p equals 1. All right, next one. -3. There's a couple ways you could do this one. You could just cancel both negatives right now. There's 2 negatives on a fraction. But if you didn't see that and you went ahead and multiplied, that's fine. We'll multiply off -3 on both sides. The negatives cancel when we multiply by -3. And now we end up with -27 and -p. And we're in the same boat. We're going to flip the sign on both sides, which means that positive p actually equals positive 27. All right? Hopefully you got those, and let's move on. Let's talk about today's lesson, which is two-step equations. All right, first, notice these two at the top. There's something we've already done probably about 10 times. This should look pretty easy, these two at the top. We already know how to do that. Okay, I would, on this first problem, I see a -5. I would add it and cancel on both sides, or add it and cancel, and then do the same on both sides. On this other problem, it's multiplication, so I'm going to divide off the -7 on both sides, which will cancel and leave x by itself. What if we just brought the -5 in and the -7 in from two different problems, and we now have a two-step equation? We went from a one-step to a two-step by simply bringing those two together. How would we solve that larger equation? Well, good news. It's exactly the same as one steps. You already know how to do it. Okay? The only question is, should I first target the -5, or should I first target getting rid of the -7? Okay? Remember, we're number assassins. We're just canceling out these values to get the x by itself. And we do the exact same thing we did on one steps. We just need to know where to start. Which guy should I cancel? All right. The answer is, if you look over here, we've got PEMDAS on the right. We're not going to follow PEMDAS order because that's how we solve an equation. That's how we normally simplify. But what we're doing when we calculate out an answer, I should have said, with normal numerical stuff. But when we've got a variable and we've got an equation, we're actually undoing it to figure out what x is. We're actually canceling things away and getting rid of things, which means we're actually working backwards up the PEMDAS acronym. We're going to go opposite. So if we look here, add and subtract, they're always together as a block. We do them together. Multiply, divide, always done together as a block. So actually, we start with the add subtract value and cancel that first. Then we go to the multiply divide and cancel it second. Another way to think about it that I tend to use when I'm solving is we work from the outside in. So this -7 is right next to the x. It's right next door. It's the closest term. But this -5 right here, he's farther away. He's more outside, more distant from the x in terms of operation and in the equation. And we're going to start with that -5 because it's an add-subtract term. Okay, so if we were to write that out before we even solve, we're going to first cancel -5, then we're going to cancel -7. Okay, that's important. Really important for you guys to grab while we're working here. Always start with the add subtract term, then we'll go second to that multiply divide term. Let's do that. All right, let's go ahead and solve one. All right, what we were just talking about is the first thing we're going to take out is the add subtract term. Okay, there's two things we're going to try and cancel. We need to cancel off the -8, and we need to cancel off the -7 to get that x by itself. And we're starting with -7 because that's the add subtract term. It's more distant from the x, if you want to think about it. It's reverse PEMDAS, but you always cancel that add subtract term first. So I'm just going to do a +7. It's going to cancel away, and I'm going to do the same on both sides to keep the equation balanced. That's 31 bad guys, 7 good guys. I'm going to end up with 24. Now at this point, just bring down what we had and keep working with it. All that's left on the left side of the equation, pun intended, is that -8x. That 7 term, that -7 went away. So we just have the -8x left over. Now we're going to continue just like it was a one-step. We're going to get rid of that multiply divide term, just like we always do. Since it's multiplying, we will divide. Both the number and the negative need to divide off and cancel. On the other side, that pair of negatives also cancels. 24 divided by 8 is 3. And there we go. All right. So first, just answer these questions for me. Don't even solve that guy yet. Just answer these two questions. What are you going to cancel first? What are you going to cancel second? Write that down. Go. Okay, remember PEMDAS tells us the add subtract term first. That's that guy right there. So we're going to cancel off the +3 first. What are we going to cancel second? Any multiplier divide term. Let's reverse PEMDAS. So we're going to cancel off the -9 second because that's a multiplier divide. All right. Let's do one of these together. I'm going to work the example on the left to solve it. You can work the example in the middle at the same time. We'll partner together. And right over here on the right, we've got our rules to remember. We're going to first cancel the add subtract value. So get that green one copied down if you don't yet. And I'll work through while you work at the same time. So the add subtract value for me is +4, excuse me, it's the +4, which I'm going to use subtract 4 to cancel. Okay, what are you going to cancel? Do that right now. And now let's do the same on both sides. Remember, we're canceling the add subtract term. I've got bad guys and bad guys. So I'm going to add that together. And then what's left over is that multiply divide term. I'm going to bring that guy down. Go ahead and you guys do the same thing. And if you need to, pause it till you can do each step to catch up with me. So now you should have just a one-step equation left also with just your multiply divide term. Okay, over here on the right it says now solve that multiply divide one step that's left. Just like we always do. It's multiplying, so I'm going to divide, which I'm going to divide off everything with the x. I'm going to do the same on both sides to balance my equation. And I'm going to get 3. All right, you finish, and then I'll show you your example problem. You can see if you did it right. Okay, let's jump in. First, you should have canceled that negative 12 with a positive 12. And then we'll do the same on both sides to keep it balanced. You end up with 18 on the right side. And we're going to bring down whatever we have left, which is 9p. Now we've got that multiply divide one step. It's multiplication, so I'm going to use division to cancel it. And I'm going to do the same on both sides, which means you should have ended up with 2. If you did, good job. All right, here's a couple of problems for you to practice on. Don't pause it yet. I want to point something out on number 2, highlighting right there. I might have already pointed out earlier in the video, but I don't remember. 6 minus the 4m on number 2. A lot of kids would see the minus 4, and they might think that's a subtraction, therefore I need to add to cancel the 6. But think about it. Is 6 plus 6 going to cancel? Is that good guys and bad guys, or is that just going to add to 12? So it ends up we wouldn't cancel anything. So notice that 6 is positive. What do I need to bring to cancel the positive 6? I need to do a negative 6. 6 minus 6 is going to cancel to 0. Same on the other side, makes negative 12. And then we can bring down the minus 4m and divide off the negative 4 on both sides to finish. Let's give you another problem like that so that you can actually practice as well. All right, there you go. Pause it and work through number 1 and number 2 now. Go. All right, number 1. I'm going to cancel the add subtract term first. It's a positive 5, 5 good guys. I'm going to get rid of him and do the same on the other side. This is 2 negatives, which is just bad guys and bad guys going together. Larger group of bad guys. Should get negative 13. And I'm going to bring down what's left over, which is just that multiply divide term. We're down to 1 step. So now to get rid of that 3, it's dividing, so I'm going to multiply to cancel it, always using the opposite operation. And we end up with y by itself on the one side, which we want, and 3 times negative 13, negative 39 on the other side. All right, let's look at number 2. Always start with the add subtract term. That's a positive 8, 8 good guys. I need to bring 8 bad guys to cancel them. Another example of 2 groups of negative, 2 bad guy groups just going together. Negative 12, bring down what's left. We have a negative 3p on the left, negative 12 on the right. And we got to cancel that negative 3 off of p. Since it's multiplying, I use divide, and I divide off the number and its negative sign, so that p is by itself. Same on the other side. That pair of negatives cancels when I divide. 12 divided by 3 is 4. I hope you got that before me. All right, guys, do the homework. See you tomorrow.